This video will cover beginner questions regarding the topic of implicit differentiation. The first one, d dx of x to the power of 4 equals 4x cubed d dx of y to the power of 4 equals 4y cubed times dy dx, or we can rewrite as 4y cubed times y prime. It's just like chain rule, or think of it as y equals 3x plus 2, then d dx of 3x plus 2 to the power of 4 equals 4 times 3x plus 2 cubed times 3x plus 2 prime. Then this one is y, so 4y cubed times y prime. If you still don't understand, think about chain rule the other way. When y equals 3x plus 2 to the power of 4, then let u equals 3x plus 2. Then we can rewrite as y equals u to the power of 4. Then d dx of y equals d dx of u to the power of 4. Then dy dx equals dy du times du dx. Then dy du equals 4 u to the power of 3 times du times dx, or we can rewrite as 4u cubed times u prime. So d dx of u to the power of 4, this one, equals this, which is 4u cubed times u prime. If you put y instead of u, you will see d dx of y to the power of 4 equals 4y cubed times y prime. To differentiate y to the power of 4, we use the chain rule and keep in mind that y is a function of x. Or you can think this way, d dx of y to the power of 4 equals dy to the power of 4 over dx. When we differentiate y to the power of 4, we need the d dy. So times dy over dy equals dy to the power of 4 over dy times dy dx. Now we can derive y to the power of 4, which is 4y cubed times, keep the last one, dy dx. Or we can rewrite as 4y cubed times y prime. Number 1, x squared plus y squared equals 25 is the equation of the circle with a radius of 5 and the center of origin. Then y equals 25 minus x squared. Then y equals plus minus square root of 25 minus x squared. Above the semicircle is y equals square root of 25 minus x squared. Below is y equals minus square root of 25 minus x squared. Then 3, 4 is on the curve y equals square root of 25 minus x squared. Y equals square root of 25 minus x squared equals, we can rewrite as 25 minus x squared to the power of 1 over 2. Then dy dx equals 1 over 2, the inner function to the power of minus 1 over 2 times inner function prime, which is 25 minus x squared, 25 minus x squared. Then we can rewrite as 1 over 2 times 1 over square root of 25 minus x squared times minus 2x. Then cancel, minus x over square root of 25 minus x squared. dy dx when 3, 4 equals minus 3 over square root of 25 minus 3 squared equals minus 3 over square root of 25 minus 9, then minus 3 over square root of 16. The final answer is minus 3 over 4. Number B, d dx of x squared plus y squared equals d dx of 25. Then we can rewrite as d dx of x squared plus d dx of y squared equals 0. The first one is 2x plus the second one is just use a chain rule, 2y times dy dx equals 0. Then move 2x to the right, 2y times dy dx equals minus 2x. Then divide by 2y on each side, dy dx equals minus 2x over 2y. Then dy dx equals minus x over y. Then dy dx when 3, 4 equals minus 3 over 4. We have the same answer, and using implicit differentiation is more easier. Number 2, we can rewrite as d dx of x plus d dx of 2y equals, just to think of it as chain rule, the first one is 1 plus second one 2 times dy dx. Question 3, we can rewrite as d dx of 3x squared times y cubed. Then use the product rule, d dx of 3x squared times y cubed plus 3x squared times d dx of y cubed. The first one, 6x times y cubed plus the second one, 3x squared times, use the chain rule, 3y squared times dy dx. The final answer is 6xy cubed plus 9x squared y squared dy dx. Question 4 equals 3x plus y to the power of 2 times d dx of x plus y equals 3 times x plus y squared times the first one, d dx of x plus d dx of y, then 3 times x plus y squared times x prime is 1 plus y prime is 1 times dy dx. The final answer is 3 times x plus y squared times 1 plus dy dx. Or you can do d dx of x plus y to the power of 3 equals 3 x plus y squared, then x plus y prime, use the chain rule, 3x plus y squared, then x prime is 1, then y prime is just y prime. Number 5, we can rewrite as d dx of x times y to the power of 1 over 2. Then we can differentiate the outer function first. 1 over 2 times x times y to the power of minus 1 over 2. Then derive x times y equals 1 over 2 times back to the radical form. Then use the product rule, d dx of x times y plus x times d dx of y equals 1 over 2 square root of xy. Then first one is 1. Then keep the second one plus keep the first one. The second one is just dy dx. The final answer is 1 over 2 square root of xy, y plus x times dy dx. Or we can rewrite as d dx of xy to the power of 1 over 2. Then use the general power rule. 1 over 2 xy to the power of minus 1 over 2 times xy prime. Then 1 over 2 times 1 over square root of xy. Then use the product rule. X prime y plus x times y prime equals 1 over 2 square root of xy times x prime is 1 times y plus x times y prime is just y prime. The final answer is 1 over 2 square root of xy times y plus x times y prime. Question 6. Use the quotient rule. UB prime is u prime b minus ub prime over v squared equals d dx of y times x minus y times d dx of x over x squared. The first one is dy dx times x minus y times 1 over x squared. The final answer is x times dy dx minus y over x squared. Or we can rewrite as xy prime minus y over x squared. Question 7. d dx of square root of x plus square root of y equals d dx of 4. We can rewrite as d dx of x to the power of 1 over 2 plus d dx of y to the power of 1 over 2 equals d dx of 4 means 0. Then the first one is 1 over 2 x to the power of minus 1 over 2 plus differentiate the outer function first, 1 over 2 y to the power of minus 1 over 2 times, then differentiate the inner function, which is y prime, equals 0. Back to the radical form, 1 over 2 square root of x plus 1 over 2 square root of y times y prime equals 0. 1 over 2 square root of y times y prime equals minus 1 over 2 square root of x. Then times 2 square root of y on each side. Then y prime equals minus 2 square root of y over 2 square root of x. Then y prime equals minus the square root of y over square root of x. This is the last one. d dx of x cubed plus d dx of y cubed minus d dx of 3xy equals d dx of 3. The first one is 3x squared plus the second one use the chain rule 3y squared times y prime minus the third one we can rewrite as 3x times y equals 0. 3x squared plus 3y squared y prime minus, use the product rule, 3x prime times y plus 3x times y prime equals 0. 3x squared plus 3y squared y prime minus 3x prime is 3, y plus 3x times just y prime equals 0. Then expand 3x squared plus 3y squared y prime minus 3y. minus 3xy prime equals 0. 3y squared y prime minus 3xy prime equals minus 3x squared plus 3y. Then factor 3y squared minus 3x times y prime equals minus 3x squared plus 3y. Then y prime equals minus 3x squared plus 3y over 3y squared minus 3x. Then we can simplify minus x squared plus y over y squared minus x. Y prime when 2, 1 equals minus 2 squared plus 1 over 1 squared minus 2 equals minus 3 over minus 1. The final answer is 3. Or when you have solved this far, put in the numbers 3 times 2 squared plus 3 times 1 squared y prime minus 3 times 1 plus 3 times 2 times y prime equals 0. 3 times 4 is 12 plus 3y prime minus 3 plus 6y prime equals 0. 12 plus 3y prime minus 3 minus 6y prime equals 0. Then minus 3y prime equals 12 minus 3 is 9. Then minus 9. Make positive y prime equals 3. Then you will see the same answer. I hope this video has been helpful. If you have any questions, leave them in a comment below, and I will address them in a future video. Thank you for watching. Please like and subscribe for more.